For the same question, they ask for the same data where we have process P and Q and then the semaphores S and T, and now they are asking that, say it, which of the following will ensure that output will never contain a substring of form 0, 1 power n 0 or 1, 0 power n 1 where n is odd. Which means in the earlier one they have asked us how to print some sequence, and now they are asking that how to print a sequence which does not contain this subsequence, right? So which means you should try to see, test all the options using which this pattern should never be printed, right? Let's see one by one options and then we can eliminate which one is right and which one is wrong. Watch this one first. Let's see option A. Option A is saying that at W it is P of S, here it is P of S, and at X it is V of S, and at Y it is P of T, and at Z it is V of T, right? And then they are saying that both S and T are initialized to 1, S equal to T equal to 1. This is the condition. Now watch it, what happens. See, process P can enter into this printing loop only when it can take control of S, and S is having an initial value of 1, therefore process P can enter this printing sequence at any time it wants. And similarly, if you look at process Q wants the control of T before it could enter into the printing sequence. Therefore process Q can actually enter into this loop anytime it wants, right? So now both the process P and Q can enter into the while loop anytime they want, and again when they are inside the critical section they could even get preempted also, right? So now assume that this, and I'm just giving you some sequence. One sequence is process P will start and perform the down on S, and it is successful, therefore it could enter this line and print. Let us see the line. It is 1, 2, 3, 4, and process P could print line number 1, which means it will print 0. Yes, which means it will print 0, right? And then it got preempted, and then process Q came into an execution, and then process Q also entered the critical section, not the critical section, this printing loop, and now it has performed down on T and it is successful because T is initially 1. Therefore process Q also can enter the critical printing section, and assume that it has executed line 3 and 4, which means it printed, or assume that it has executed only line 3, which means it printed 1, and here it got preempted. So P got preempted after 1 and Q got preempted after 3, and again P got execution, and let us say P is now at line number 2, therefore it will print 0. Now watch it. It is nothing but 0, 1 power n 0 where n is odd number. Therefore with this option A, right, it is possible. 0, 1 power n 0 is possible. Even in fact it is also possible 1, 0 power n 1. You can test it out. How? If initially instead of P, Q gets into the printing loop and Q prints 3 and then Q executes 3 and gets preempted, and then P gets into the loop and then prints 1 and preempted, the same sequence, then it is going to be 1, 0 power n 1. So this option is going to be invalid. The reason is it is able to print the sequence. And next one is, let's see the B option. B option says that at W P of S and at X it is V of T. Here it is V of T, right? And then at Y it is P of T, and at Z it is V of S. Fine. And both are initialized to 1, S equal to T equal to 1, right? Now watch it, what happens. So in this case what happens is both P and S, both P and Q, process P and Q can enter into this printing loop simultaneously, because they are actually performing down on different semaphores, and both the semaphores are having initial values of 1. Therefore any down on here or any down here will be successful, and both the process can enter into the printing loop simultaneously. Again the same thing can be happening, right? What? P can print 1, which means P can execute 1 and print 0 and get preempted, and then Q can execute 3 and then get preempted, and again P can execute 2 and then get preempted, and again Q can execute 4 and then get preempted, right? Therefore 0, 1 power n 0 where n is odd is here also possible. So B is also not the option. Now let's look at C. C is saying that at W it is P of S and at X it is V of S, and at Y it is P of S and at Z it is V of S, right? And only SC is used. If you look at this option, only SC is used. T is never used as a synchronization mechanism, and initially S equal to 1. So initially S equal to 1 and only SC is used. So what can you say about it? Now both the processes are just using only one semaphore to enter into the printing sequence. Therefore what you can be sure about is, see, both of them are using only one semaphore, which is S, and which is initialized to 1, right? So what happens is, either process P will enter this printing loop or process Q will enter the printing loop, but not simultaneously, right? And then once one of it comes out, then only next one can enter, right? Similarly, once this one comes out, then only next one can enter. Therefore either you execute the sequence 1 2 and then followed by 3 4, or 3 4 and then followed by 1 2 atomically, right? So actually whenever you use only single mutex, it acts like a critical section, right? And now this critical section, only one process can be present inside the critical section. So in this case what happens is, either we can run 0 0 1 1 or 1 1 0 0, right? Or any sequence, which means 1 1 here, 0 0 here, or 1 1 0 0 1 1 here. All the sequences are possible, but then just preempting, even if you get preempted after printing 1 0, you cannot print 1 1. The reason is you cannot enter this printing sequence, right? So always 2 1s will be there or 2 zeros will be there. Therefore there will always be even number of 1s followed by even number of zeros, or even number of zeros followed by even number of 1s, or plainly even number of 1s or even number of zeros, right? Even this is also possible, 1 1 1 1 1 1 1 1 or 0 0 0 0 0 0 0 0. Anyway, you will never see anything as 1 0 power and these two. You will never see anything like this. Got it? And next one is, at W it is V of S. At W it is V of S, and at T it is and at X it is V of T, and at Y it is P of S, and at T it is and at Z it is P of T. P of S and P of T, right? So here both ups are taking place and here both downs are taking place, and both are initialized to 1, which means both S and T are initialized with one value, with the value of 1. So here S equal to T equal to 1, and this is the case. Then what happens is, watch it. So at any time, we are not performing any down operation, therefore P can enter into this printing sequence anytime without getting blocked at all. Only sequence which will block is down operation, but here we are doing up operation, right? Therefore P can enter this printing sequence at any time without getting blocked, right? And now Q, initially whenever this S equal to 1, isn't it? So whenever S equal to 1, because S is equal to 1, right? So initial call will definitely not block it, and therefore it can also enter into this, right? Now see what happens. Now both of them can enter into this critical, printing sections at the same time. And now if P entered this and it has printed 1, which means 0, and Q entered this and it has executed line number 3, which means 1, and again it got preempted, and again P, it executed line number 2, then this sequence is possible. So definitely even with D also this sequence is possible. Only one pattern which does not guarantee is C. See, it might look like I am taking a lot of time to do this, and therefore you might feel that these questions will take a lot of time in exam, but believe me, if you practice this well, these questions will be the easiest questions. You can answer them just by looking at the question. With practice it is definitely possible. So don't worry, operating system synchronization is the easiest topic. In fact, operating system is the easiest topic, as long as you have such problems without any theory. Okay, so even though it took a lot of time, with practice you could cut down the time, right?